Welcome to the show, everyone. It's the Crypto Lark. Today, I got to sit down with a team from Arweave to discuss their upcoming token sale, mainnet, and what the heck a Blockweave is. We're going to get into that interview after a few quick reminders. First being, this is not financial advice. These are just the opinions of a dude talking about cryptocurrencies on the internet. This is an ICO. DYOR. Do your own research, do your own diligence. There are always a certain amount of inherent risks in investing in any ICO. Know the risks before you get involved. Unfortunately, though, for Arweave, the whitelist has already closed. However, mainnet is launching super soon, so tokens should be available for trading for those who find the project compelling. One farther note, the team at Arweave has reached out for me to do a sponsored interview of their project, but I have, of course, reserved the right to ask any kind of fun questions and keep it open and honest as always. So let's get into it. Today, I got to sit down with Sam from Arweave. Sam, welcome.
Thanks. Great to be here.
Can you tell us the short version? What is Arweave? What are you guys trying to do?
Sure. Arweave is a permanent information storage platform on a modified kind of blockchain that we call a Blockweave. Essentially, what the Blockweave allows you to do is scale up the amount of storage space available on the chain itself, the blockchain, and then share out that information storage across many different computers and reward miners for storage of data, as well as hashing. But basically, the more data is stored in the system, the less hashing has to happen.
Very good. I like that's a good ding. Good elevator pitch. Excellent. It's one of the better ones I've heard in a while. Now, what is the problem that you guys are trying to solve? Why is data a problem? Why are blockchains and data? What's going on with the problem there?
Well, I mean, the real problem that we're trying to solve at the base of it is the fallibility of collective human memory. This idea that as a group, even now when we have the internet, we're very good at sharing information across geographic spaces quickly, but we're not very good at remembering that information for extremely long periods of time. And we got started with this project because we saw that blockchain allowed you to kind of solve that problem if you could solve the scaling issues. So we put our minds to the scaling issues, and then here we are. Interesting.
Yeah, it's amazing how much knowledge actually just gets lost by data hacks and things like this. And I've always been of the mind that one of the greatest tragedies as far as data in human history was, the fire at the library at Alexandria a few thousand years ago. They didn't have, a Blockweave to back everything up on. It would have been very useful for them.
Yeah, we're essentially trying to make the Library of Alexandria the information age, if you like. The interesting thing about the fire at Alexandria, actually, and I only found this out when I was looking it up, because I was, we just went through Techstars, the startup accelerator, and on the demo day, you do a pitch. So I thought I'd mention the library in the pitch. But it turns out that the library didn't actually have just one fire. We've actually lost all of our records of losing all of our records in the fires. It's crazy. It's just the extremity of the problem.
And of course, that was a few thousand years ago, and there wasn't quite as much data floating around then, but it was, essentially a centralized server when it comes down to it. But the data problem that we've seen recently is since I started using the internet and you started using the internet back in the 90s and stuff, there wasn't that much data. But now the curve on the data is just going absolutely exponential. And so why is this exponential data increase a problem? Why do we really need to have new solutions for that?
Well, as far as I see it, there's two fundamental classes of data storage. There's ephemeral storage and long-term or would-be permanent storage. So, like I said, we're pretty good at the ephemeral storage now on the internet. Actually just Filecoin, Seer, and Storage, do well enough.
Yeah.
Decentralized storage of data for ephemeral usage. But we just don't have a permanent collective backup system, which is really what the Arweave is looking to solve. But because of the way that we've done it, which is essentially building a consensus algorithm that involves the long-term storage of data, rather than just having as those other systems do. They have like an off-chain data distribution and storage mechanism, and then they settle payments on the blockchain. Mm-hmm. We've actually put the data on the blockchain and made that data storage part of the consensus algorithm. So in doing so, we can actually offer the storage pretty cheap, which is kind of interesting, because the value the miners would just otherwise expend on hashing. So
yeah, absolutely.
Storage is cheaper. I'm good with that.
Long-term storage of things on the blockchain is super powerful, and there's a lot of concepts about this technology and things we can put, like land registries. That needs to have a permanent life on a blockchain somewhere because it can't be altered, and it needs to sit there for 100 years if necessary, maybe longer, right?
Yeah, and stuff like underground maps of like where the water pipes are. I'm sure, I live in Germany now, but in the UK and Germany actually, I see them all the time digging up the roads to try and find out where they've put the water pipes. It's like, if you just made a record of that and stored it somewhere permanently,
it could be accessed on an app on your phone like that.
Yeah, maybe we could make society substantially more efficient. And the same, I have, I don't actually know what relation to me he is. He's someone in my family. I go climbing mountains with him sometimes. He works on oil pipelines in Iraq, checking the integrity of the pipes. and they have some of these pipelines. They don't actually know which oil wells they connect to. So they're just spewing out oil all the time. And like someone's got ownership of the end point of the pipe. But like they have no idea where that oil is coming from. It's completely crazy. The amount of stuff that like humanity just needs to store permanently and openly is really, pretty high.
That's right. The access to this information is so important. That story just gives such a good example of why we need to have the access to this information on a permanent record somewhere, because people forget, things get lost, fires happen, all this stuff. How do you prevent blockchain bloat? If we're going to dump all this stuff onto a storage structure like the Blockweave, how do you prevent it from just becoming some giant monster that is no longer functional?
So the answer is you kind of don't, but you change it so that not everyone has to have all the blocks for a start. So you can join the system and get going just by downloading the last block. And then for every subsequent block you download, you are rewarded by being allowed to enter the hashing competition. So if you own 10% of the blocks, you can take part in the hashing competition for mining new blocks 10% of the time. And this means that you're heavily incentivized to optimize for the amount of storage you make available. And so you're just rewarded for it. But if, for example, you have a block that only a couple of other people have, that's not likely, but only 20, 30 other people have, then you're competing against a very small pool for mining the reward for the next block. And so, more blocks, more blocks, higher likelihood of reward, and more data stored in the system, less hashing, more competition about data storage.
Interesting. Can you break it down for me in a real simple way? What are the key differences between a Blockweave and a blockchain, and in which ways do you see a Blockweave being superior in some cases, and in which ways do you see a blockchain being superior in some cases?
Yeah, sure. So the Blockweave, the essential thing is, and why it's called a weave, is that as well as including the hash of the last block in the system, we also include the entire contents of a previous block in the system, as well as the new transactions that you're attempting to mine in the production of the next block. And this sort of leads seamlessly to this idea of proof of access, which is the consensus mechanism we use. Mm-hmm. So this is that you need to prove that you have access to a randomly chosen previous block in the network in order to take part in the generation of the next block. And because you don't know what block is going to be required for block n+1 until block n is mined, the most efficient strategy is to store as many of those old blocks as you can. So there's that side of it. The Blockweave is essentially an extensible blockchain that scales. The one thing that it's not so good at is stuff that we don't do, for example, like smart contracts. Mm-hmm. But we have an entirely different decentralized application architecture, which I think is actually preferable for most kinds of applications that people really want to build. So I've told this story so many times now that it feels...
I haven't heard it yet.
Yeah. Sorry, I bought the Ethereum presale, and I wanted to build like decentralized web applications. That was my idea. And then, basically it didn't pan out that way. You just can't really do that. And I still think that's a great shame, because I think, when we go outside of our little community and we talk to people about the idea of decentralization and what it can allow you to build as a programmer, people want to build web applications. They want to build social media systems or blogs or that kind of stuff. But we just don't offer them that at the moment. So what we've done with the dApp architecture with Arweave is made it so that we decentralize the storage rather than decentralizing the computation. And this works perfectly for those kind of create, read, update, delete, although in our case, we don't delete. So create, read, update web applications. Stuff like a decentralized Twitter or Facebook or even YouTube.
Very interesting. Okay, I wanted you to break down the proof of access consensus mechanism. I know you mentioned it a little bit already, but really, how does proof of access differ from like proof of work, for example?
So proof of work is actually nested inside proof of access. So one of the ways of thinking about it is the more blocks you have stored locally on your computer, or this is why it's not proof of storage, it's proof of access. You simply can access when necessary. So maybe you actually pay some other person to store it for you. It doesn't matter to us, just as long as you can access it on request. So they're kind of like lottery tickets. The more of them you have, the more likely you are to be able to play in the game. And then there's also the hashing competition on top. So if you have 50% of the blocks, 50% of the time you'll be able to take part in the hashing competition. 100% of the blocks, it's just proof of work, essentially. So when the network starts, everyone has all the blocks. It is essentially proof of work until people start dropping out and saying, okay, this is too much data for me. And then they've got holes in it, and they essentially leave other people to mine on those recall blocks that they don't have. And this essentially creates this competition over storage, which is fantastic from the point of view of the network, because it just means that people are competing to have as many redundant copies of the data as possible. And they're economically incentivized to do so.
Which is why it works. Now, you guys are doing 5,000 transactions per second, which is very impressive. Obviously, you've been running that on the test net, right? So we've up to 5,000 transactions per second already. The cheap on-chain storage is also great. How, I guess, through the Blockweave infrastructure, how do you actually lower that on-chain storage cost? Why is it so low?
So the key thing is that you're just offsetting value that miners would spend on hashing already when you add data to it. So from that point of view, I mean, it could be exceedingly cheap if you took that to its logical extreme. But we've made it so that it's a reasonable price. So miners are still being rewarded very heavily for taking part in the network, on top of the fact that they're performing this service, which is to them, you're either guessing random numbers or you're storing useful data. It doesn't make any difference to the miner.
Mm-hmm. Now, you guys have something called Wildfire. Great name, but what is Wildfire?
So it's an incentivized it's an incentivized data distribution layer, essentially. So we have this, Blockweave structure. It's great. You put data on it, it's incentivized storage. But you got this problem, right? Which is like, how do I get the data off there? No one's incentivized to give it to me. So essentially what we made was a system called Wildfire, which can be abbreviated to, if you give me data quickly, I'll give you data quickly. And in order for us to work well together in a blockchain, like in order for us to be efficient miners, or a Blockweave in this case, we have to have access to data quickly. So if you send me data quickly, I'll send it to you quickly. And if you don't respond to my requests, then I'll drop you. And because there's actually like a limited number of slots of connections each individual node will make in the network, you actually really have to compete to stay part of the network. And so in doing so, we incentivize people to use high quality data lines. And the great thing about this is that it's not just the quality, it's actually at a basic level, what we're doing is we're capturing the amount of time it takes to transfer a transaction, a number of bytes, and then we're working out what the average transmission rate is, inclusive of latency. But what that means is that if you're in Tokyo and I'm in Beijing, then we have a reasonably strong connection. But if you're in New Zealand and I'm in Berlin, then our connection will be very weak. Mm-hmm. So what happens is the network adapts to the geographic, the geographic layer on which it's actually sitting. But it's not even that. It's that it maps onto the substrate of the internet, like the actual underlying wires, and yet produces efficient lines of communication throughout the global system.
Very cool. How do I become a miner? What do I need to become a miner? Is it GPUs, or can I do it on my desktop computer? Can I do it on my laptop? Can I do it on my phone?
So you need hard drive space, primarily. That's number one. Then you need CPU power. And then you need, some kind of reasonable bandwidth.
Pretty easy. So essentially, most people should be able to become a miner on the Blockweave, right?
Yeah, completely. It's much more open than other mining environments, I think.
That's cool. Yeah, I know some of the other mining blockchain storage guys, they've actually got ASICs being built for them now, whereas I like the idea that you can just mine from your home computer, of course. Are you worried about ASICs as a kind of a long-term thing? Could you see those coming in and messing up what you guys are doing, or are you kind of resistant to that?
So there's two sides of it, which is that actually ASICs are really expensive. So our imperative in the system is to make sure that the hashing part is very expensive and the storage part is comparatively cheap. This, you make sure that miners are incentivized to provide that useful service to the users in order to take part in the consensus mechanism. So there's that side of it. And the second side is that it's extremely difficult to make a mechanism that is actually ASIC resistant. And the SEER guys actually wrote a really interesting blog post about this recently, where they were basically saying, look, Intel internally calls their machines, their CPUs, ASICs, right? Because they're just another kind of special purpose device. But basically, all of these devices are on a spectrum between special purpose and general purpose. And so you can plausibly make a kind of an ASIC that could be used for lots of different mining configurations that just has some level of generality to it, rather than total specificity. And so the general conclusion to this was that, you're not going to be able to solve ASIC mining. But the bit that I think they missed, which is really interesting, and Simon from Loki, which is another great project you should check out. We were talking about this at Consensus at New York. And basically, there's this idea of GenProg, which is that you generate a random field of programs, which are, of course, all general purpose computations. So you can't build a specific device to perform them. And then you somehow test that the user has run a program, or maybe found a program that does a certain thing across a certain field, which performs a proof of work. But in doing so, critically, you couldn't build a piece of hardware that was any more specialized for this than a general purpose CPU, because it's doing general purpose computation. After we spoke, I came up with this idea that basically what you do is you take a random number, use it as a seed, or you seed a random number, you generate a random string of instructions. Maybe this is, I don't know how.
Let's do it. Let's go for it. I'm into it. Let's do it.
So you generate a random string of instructions, and then everybody, say you use the hash from the last block, perhaps, to do this. You generate this random field of instructions, and then everybody takes a random position in that field as part of the proof of work and runs it for, say, 1,000 steps or something. And the idea would be to get to a certain output. Like, I don't know, the output's got to be the number 1337, something like this. And so then it basically, because you've done that work of finding the start position, people will be able to, so proof of work has to be hard to find, easy to verify. Yeah. So they would be, the hard to find bit would be finding the right starting position in the program that will actually allow you to execute it for n steps and then come out with the number that you were looking for. Yeah, and it's easy to verify because when you just transmit as the proof of work instead of the nonce, here, start at this instruction, and it just works. Which I think would be, but we haven't implemented that yet.
Okay, interesting. A little bit tech dive there for everyone listening. That's great. I certainly appreciate a little bit of these tech insights, without a doubt. Now, let's move on to the next idea here. Block shadows. What are these?
Yeah, so this is essentially a new way of distributing. Well, it's not really. Yeah, it's a way of decoupling the way that transactions and blocks are distributed around a network. So normally, what you do in a blockchain is you take a transaction, or rather, you're given a transaction by another node. You verify it. You send it to all your friends, and then you start mining it into a block. If you're the one that's lucky enough to mine a block, you distribute that whole block to all your friends. There's a critical inefficiency here, which is that you've distributed that transaction once already, and now you've put it inside a block and you're distributing it again. Now, maybe this doesn't matter so much for blockchains that don't have very large transactions, but of course, because we're doing on-chain storage that scales, it's a major problem for us. Like you get a really big transaction in there, and then you have to distribute it to everyone, and it just screws everything up. So we were looking at this, and so obviously the problem that you're attempting to get around by distributing all of the transactions inside the block, rather than just what we, I suppose, now call a shadow of the block, which is just basically the building instructions that say, okay, put these transactions in this order, and then with this nonce and this previous hash, you'll find that if you add them together, you've got a new block, and it works like this. So that's a block shadow. You can think of it like as a building instruction. But the reason that people weren't doing that was because they couldn't be sure that each of the nodes in the network was going to have the data necessary to build it locally from their local transaction cache.
Essentially, you have 100 different sets of the building instructions that go out, but some people are missing pages, so they can't build the building.
Yeah, exactly. So there's like an interesting information theoretic thing going on here. So one approach to solving that problem might be to, okay, well, you ask everyone, or you get everyone to ask the person sending the block, can I have these and these transactions? I don't have them already. But this obviously doesn't work. And from a network programming point of view, like you're deliberately trying to optimize for as little data transfer as possible, as few connections as possible as well. So what we realized is actually you just abuse time here. There's this really interesting paper that was written about information distribution in the Bitcoin network. And essentially it shows you how long it takes to distribute, a megabyte of data throughout the network. And what you can do with this information is you can work out probabilistically how long you need to wait before a transaction is going to be distributed to everyone else. And so you don't need to ask them. If you wait until, say, 99th percentile probability that everyone else has got the information. And that's essentially what we do. And that sounds like it adds a big delay, but it actually isn't. For like a financial transaction, I think it's in the range of 30 to 40 seconds. And for, like much bigger data storage transactions, we're only talking about a few minutes. Yeah, so you can use this system that abuses information theory, I guess. To let you know that everyone else in the network is going to already have the information, or at least more than 50% of them, right? It doesn't actually matter if, one miner drops off every few blocks. It's really not so important.
That's right. Well, it's going to happen anyway, so better not be important, right?
Yeah.
Let's switch over to the other players. Let's not call them the competition, but Coin, Storage, they're already really well established as far as being blockchain data storage guys. How do you plan on, getting into that market and competing with them? And as a second question, you can follow up with, we already have these data storage giants, in the form of all the big existing tech companies. So how do you kind of try and find the edge in there, or are you going to try and work with them? So
I think the thing that we're offering is at some level fundamentally new. Like, yes, you can use it as just a data storage system. It works really well for that. It scales, it's good. But I think what we're offering as a core unique selling point is something that, well, humans have been attempting to do since the Library of Alexandria, actually much, much before that. Which is permanent information storage. Like, if you want to store things for long periods of time, we're the place to go. It's nuke-proof, we like to say. You know, there'll be enough nodes around the world, and all cryptographically verified too, that in the event of nuclear war, or you just forget a piece of data and you leave it in a filing cabinet and then you lose access to, it's just not going to disappear from the system.
Really cool.
That's a unique zone, I think.
Yeah, there's a lot of interesting use cases I was reading about. It's so much more than data storage, data sharing, it's data collaboration, it's IDs and all these different things, and as well as just being this. I love the philosophy behind what you guys are trying to do, a record of data. It's such a simple but such a hard thing to do considering human society, I think.
Right.
Now, what about your team? So can you tell me, I guess, kind of about the team and what skills might you guys be lacking that you think would be some places you could improve on, or who might be some personnel that you're lacking that you might want to be hiring?
Yeah, so we're a team from academia, basically. Will and I were doing our PhDs. I was building a distributed operating system before we got started. And Will was working on convolutional neural networks and various simulators for them. And that's meant that we've gone from, inception to here with network launch in 9 days in just over a year, which has been great. But of course, it means that we're lacking in some pretty key areas like marketing. We just suck at marketing. which in some ways, I mean, we now actually have, I'm not sure if he even wants me to say his name on camera. He's very, well, anyway. Guy from QuantStamp, head of growth there. It's absolutely fantastic. He's been helping us out now, and it's been excellent. Our community's grown from around 3,000 people to 30,000 people in a month. We had 28,000 people join our whitelist. It's really incredible. I'm also very, very thankful that it only happened very recently, which meant that we were able to focus on shipping the tech. Until just a couple of months ago, really. So hiring more in that area, and also in partnerships building. And developer evangelism. That these token projects, they have kind of two phases. There's phase one, which is you've got an idea, you build it out into a system, you ship it. Phase two is now you've got to get people to adopt it, and it's a really totally different stance from the point of view of the organization. So yeah, we're hiring up for that.
Nice. Yeah, definitely the getting people to use it is a very tricky thing. It's one thing to deliver the tech. The next step, of course, is a bit harder. And you guys have already got a few different partners on board, which is really encouraging. For anyone who doesn't know as well, you guys were a TechStars incubator project. So you got that sort of high-level help from them to help push this whole thing forward. So that's really cool. You guys are only raising $8.7 million in total. Don't you know you can just, like, pick a random number, 40, 50, 60 million dollars, and just, hey, we're gonna raise $50 million, guys, and people will probably give it to you. Why did you choose to go for such a small hard cap?
I mean, we built the entire system from the ground up on what in the crypto world is a tiny, tiny seed round. It's the kind of thing that, most people will be like, it's too low, it was too small, you return it, go do something else. We delivered the entire system on that money with much to spare. So I just don't see the need, personally.
That's awesome. I love it.
Yeah.
That shows to me that you guys, when it comes time to, now you've got the money for the marketing and for pushing everything forward. You've got the tech, which is going to be delivered, by the way. So mainnet launch, it's coming up on the 8th of June.
Yeah,
that's really soon. I mean, are you guys like totally ready for it? Are there any sort of bells and whistles you're kind of finishing off that you're like, everyone's racing on the outside the door there's a whole room full of computer nerds sitting typing away trying to get the last bits of code out? Or how's the mainnet developing?
That's exactly right. Although actually I'm in my apartment here because our office is great. It's in the center of Berlin. One of the problems with being in the center of Berlin is that there's rail tracks everywhere. And there happens to be a rail track just outside our window. So I can't do any interviews there because it's a screeching noise as the streets go around. It's really awful. But yeah, no, everybody heads down for net launch. It's crazy busy.
Yeah, I can imagine. It's very ambitious without a doubt, launching the mainnet and having this token sale. And again, the whitelist has closed out for the token sale guys, but that's just a lot at the same time. But it's so encouraging. You know, looking over on your GitHub, for example, it's just full of commits, and that's really encouraging for any project. And to see the mainnet launching in a few days, I think is just awesome. And it's a very encouraging project. So very, very cool indeed.
Yeah. I mean, we're still rooting through the proof of interest responses we got, which were just incredible. You know, the stuff that people did was really, really awesome. I think we'll write a blog post about it at some point, but we got 9 days now before the net launch, so everything is
leave the blog posts until after, without a doubt. Awesome. Sam, this has been a super interesting chat. I know we're all excited to see where Arweave goes, and of course everyone's been looking forward for that mainnet in a few days, so you better get back to it and get working. But thank you so much for taking a bit of time out of your busy schedule to sit down and talk to us.
No, thanks. It's been brilliant. It's been fun.
Thank you. Thanks so much for watching the interview. Let me know what you think about Arweave in the comment section down below. Furthermore, if you enjoyed the interview, make sure you hit that like button on the way out the door. Join the conversation over at Twitter to stay up to date with all of the latest news and events going on in crypto, and for extra insights outside of what we do here on the videos. Long live the blockchain, and peace out till next time.